What the hell is solubility and solubility product? Well, according to my friend Google, solubility can be defined as the maximum amount of a substance, called a solute, that can dissolve in a unit of volume of a certain liquid substance, called a solvent, at equilibrium. In chemistry, the substance is usually measured in moles, and the volume is usually measured in liters, so it can be simplified to moles per liter or molarity. On the other hand, solubility product, or KSP, is the equilibrium constant for a chemical reaction in which a solid ionic compound dissolves to yield its ions in solution. It can also be described as the mathematical product for the dissolved ion concentrations, or solubilities, raised to the power of their stoichiometric coefficients. The value of the constant identifies the degree to which the compound can dissociate in water. In other words, it describes how soluble a certain compound is. So, when a substance has a greater KSP value, that means it's more soluble, or it has a greater solubility. Examples of solutions and solubility can be found everywhere, ranging from when you want to add sugar to your cup of tea or coffee, all the way to carbon dioxide in molten metal in metallurgy. Since it's so prevalent in our daily life, let's do a chemistry problem about solubility. This question asks us to find the KSP of calcium sulfate if we know it has a solubility of 0.408 grams in 100 milliliters of solution at a certain temperature and pressure. We also know that the MR of calcium sulfate is 136. The first thing we have to do before we try to solve the problem is we have to make the ionic balancing equation for calcium sulfate. The equation is that calcium sulfate produces calcium 2 plus and sulfate 2 minus. These two ions both have the same coefficient, which is 1, meaning they have a 1-to-1 ratio within the solution. We'll symbolize their solubilities as S. The next step is to find the value of S. We can do this by using the equation moles per liter equals molarity, since it is the same as solubility. Since we are given the mass and the MR of the solute, we can find the mole by using the equation that mole equals to mass divided by MR. After calculating that the molarity or solubility of the ions equals to 0.03 moles per liter, we can plug in the value of solubility into our KSP equation. After raising these solubilities to the power of their stoichiometric coefficients, we can calculate the KSP to be 9 times 10 to the power of 4. Notice that the value of the KSP doesn't have a unit attached. This is because KSP is a constant, so it doesn't require a unit. To end the video, here are some pictures that might incentivize you to like